Okay, we're back. I just wanted to maybe walk you through the creation of some kind of program that can read a file or whatever. And I was looking around my account and I happened to come across this file called statid.nicelyformatted.dat. It's a pretty awkward name, but if I just show you what this file looks like here. Hey, let me just show you real quick here again that nifty trick I just did, in case you forget these kind of nifty things. VI, and then, okay, if I started typing statid, well, once I got as far as STAT, there's nothing else that matches. So if I hit escape a couple times, I get statid nicelyformatted.dat, and I didn't have to spell all that out. This is the file. It's got 345 lines in it, and it's just a file from some research I was doing a while back that has station identifiers in WMO format. They're 6-digit integers, and then a token. In this case, it's a couple spaces. And then the latitude of the station and the longitude of the station. The latitudes can be negative if they're in the southern hemisphere. The longitudes, I think they're all positive, meaning that they're in the eastern hemisphere. This is actually for a domain over like Indonesia and Australia. So they should all be in that same hemisphere there. But let's say I wanted to do something with this data file, like I wanted to read these observations or whatever. Let's make a little program that could do that. I'll just call it reader. I'll make a little program called reader.c. Here, up here at the beginning, we've got to remember to have our pound include math.h, pound include stdio.h. Okay, and here's our main function. What are we going to do? We need to read that file called statid nicelyformatted.dat. Well, we're going to need to have some kind of input file pointer in order to do that, which I will stick with the habit that we got into in the lecture and call that fin for input file. And I'm going to open that file. I'm going to say fin is equal to the open of statid.nicelyformatted.dat. And we're going to open it for read. And then it's a good habit to just right away go ahead and close that file too. And we'll put everything that happens in between there, in this little area right here. But we're not that far yet. So we've got a file pointer called fin that is pointing to, on the hard drive, the address of statid nicelyformatted.dat. Is that the name? Yep, that looks like that is the name spelled correctly. Alright, and I'm going to deliberately break this program in a little bit, but first let's actually make it work. What do we want to do here? Let's say we're going to read in the stations and have it tell us, just report back the latitude and longitude of the stations. That sounds fine. So what are we going to do? Let's say we're going to read in 10 stations. That sounds like a loop. I'm going to need an integer counting variable, I'll call it I. That'll be my loop control variable. Heck, let's put in a comment here. Read in the information from some stations. Let's just say for I equals 0, I is less than 10, I plus plus. Alright, now tabbed in from there, what are we going to do? We're going to read in fscanf from the file pointer fin. We're going to read it in integer. Remember, the first thing that's in each line is the station WMO number, followed by the latitude, which is a floating point number, followed by the longitude, which is a floating point number. And we're going to call this, let's say, WMO. That's the World Meteorological Organization. If you're not familiar with that, they assign every station in the world a 6-digit number. We'll call that one latitude, and we'll call this one longitude. Okay, so we better make sure we declare these variables here. We have an integer that we're going to call the WMO, and we'll have two floating point numbers. One is going to be latitude, and one's going to be longitude. All right, so we are scanning in from the input file an integer and two floating point numbers. And notice I got the ampersands here. We'll know at a later point why we have to do that. But for now, we have to see that we have that there. So the first number is going to be an integer, and it's going to go into the variable WMO. And then the second number will be a floating point number. It'll go into lat. And the third number will be a floating point number, and it will go into lon. And then we could do something with this, like maybe printf station %d is at %f%f, just to give you an example. And what are we going to do with this here? We'll write WMO, lat, and lon. Okay, this is just a very, very simple little thing here, but we're just basically going to be writing to the screen what we found out. Station with that WMO number is at what latitude and what longitude. Alright, and then of course down here we close, and then where we have the other file. Yeah, very well may have some mistakes here. Let's find out. I'm going to write and quit to get out of VI, of course. And then I'm going to GCC this reader.c minus lm. Hey, well, there weren't any compiling errors. That doesn't mean the program works, but we'll find out. Run it using /a.out. And look what it says here. Station 920050 is at a latitude and a longitude. Remember, we did this 10 times. We were in a little loop here. And we were then at this station, and this one is at this station, at this latitude and longitude, and this one is at this one, and this one is that one, and so on. And if I went back and looked at stat ID nicely formatted, you'd see that the information matches. First we read this station, which was at this latitude and this longitude. Then we read this station, which is at this latitude and this longitude, and we just slowly worked our way through the file. There was nothing else we could do with a file because it had to be in single file. The bytes are all lined up. There's no way to get out of order. If we needed to read this one, the only way to get to this one is to first read all of these until we get to this one. That'll be a hint as to how the next assignment is going to work, by the way. Alright, where am I at here? There we go. Alright, so we have a nifty little program here called Reader that is just reading this stuff here. Just to change it up a little bit, let's also make it do some output. I'm going to add also here, I'm going to call it fout or fout. Again, that's just how when I learned how to write programming, you could call this anything. It wouldn't hurt anything. Alright. Now we're going to make this our output file. Maybe we're going to call this reformatted info. Okay. Name doesn't really mean much of anything here. And notice I gave it the modifier W here to tell us that this is a file that we are writing. Again, it's a good habit. Right away, as soon as you open a file, go ahead and add the line where you're going to be closing that file, just so you don't forget to close it later. And let's just say here where we were previously printing this to the screen, what if I just did the same thing again, but instead I'm going to say fprintf. I could have copied and pasted this, but whatever. I'm just going to print this to, I'm going to fprint this to the file. Oops, those are commas. Okay, so I'm using fprintf to write it out to the file fout, whatever file we're pointing at when we have found where to start fout. Fout will be an address on the hard drive that is blank, where there's nothing there right now, and it will be the first byte of a new file that we are creating. Alright, let's just see what happens if I do this. If I compile this guy again, I notice I'm just using the bang G command to recompile this thing. And we're going to run it again, a.out. And see how I wrote this stuff to the screen, but perhaps more importantly, notice I now have a new file called reformatted info. If I go ahead and open that file, reformatted.info, see, it's the same stuff. I just also printed it to the file for output, as well as writing it to the screen there. Let's break these programs a little bit. What if I had forgotten to to open a file? Like, I'm just going to comment out this line right here, which is where I opened my input file. Alright, what happens if I try to compile this thing? Whoops, right and quit. Compile. It compiled! Alright, what happens if I run? Nothing really. It's just sort of hanging out there, or what's going on. Who knows? We've somehow broken it. Oh my gosh, how do I get out of this? I don't know what to do, Dr. Shruggy. I'm just stuck, I'm stuck. No, here, Control-C. And it's all done. Alright, we're back. Control-C always breaks out of whatever is running on a Unix computer. Let's go back in here. What else could we break on this program? What if that was a file that didn't exist? Like let's say I misspelled a name here. I just made a name. There is no file with the name ASDFHL stat ID. What happens if that works? It still compiles, but if I try to run it, I get a very particular error that you will be seeing so many times this semester, and that is segmentation fault. Segmentation fault is a very broad type of error that computer programs can get that means they're trying to access something that they either don't have permission to get to or doesn't exist. So in this case, there is no such file as whatever that goofy name I just put in there. So segmentation fault means it's trying to access something that doesn't exist. Okay. Let me see here, what else could we do that might break this program? Again, you've already seen demonstrations where we've done things like forget the ampersands on an fscanf, excuse me. And so, just like you saw them on a scanf rather. So that's not so exciting. You've already seen that particular error. Honestly, there aren't that many things that can go wrong in this particular program that you're working on right now. What can go wrong, actually, is that your actual problem is going to involve also doing meteorological calculations. Remember, you're reading in some data from the decoded.data file, which is currently in ~shruggy_j, and you're going to need to copy that over to your home directory. Thusly, I'm just going to get out of this here. Copy from the home directory of shruggy_j decoded data to the current directory. Dot means the current directory, and see that just copied it over from my home directory to yours, and now there's a file over here. Here, let's just do an ls, and you'll see it. It is right there. All right. So there's not much going on in your program other than that. Now, your actual program is also going to be doing some calculations, like potential temperature and wind chill, if I remember right. So you're going to need to include your MetCalc libraries, which will be home, and then in my case, student 315, but whatever your login is, metcalc.c. That way you'll be able to use calculations in here, like, you know, temperature C equals F to C of temperature F, and those functions which you already know work just fine will be right there, just as much as sine or printf. Other functions are there because we've included things like math.h and stdio.h. So make sure you do that up on here, but then you'll be able to access and use the functions that you already know work, that you made a couple assignments ago. Okay, well, I think that's everything that you're going to need on this assignment. It should be pretty straightforward. Please let me know if you have any questions. This is Dr. John Shruggy.